Okay, so now we're going to do an example of Descartes' rule of signs to understand it, because just by reading it, you really have no idea what it means. All right, so consider this function given by the equation p. Find the equation of p of negative x. So this is just a little practice. You ready? So what we're going to do is we're going to replace every x value here with a negative x. And think about what's going to happen. If it has a even power, 2, 4, 6, 8, who do we appreciate? Then what happens when you raise a negative to an even power? It's going to become positive. What happens if you raise a negative something to an odd power? It will stay negative. So that's what's going to happen. You ready? We're going to show all our work. So I'm plugging in a negative x for every x. And then we'll simplify based on what we talked about. I know a lot we talk about positive and negative and even and odd, and I know as a student sometimes those get confused. So negative is positive or negative, and an even power, even is 2, 4, 6, 8. Okay, so if we have negative x to the power of 4, that will come out positive, right? So this is just going to be 2x to the 4. So essentially it did not change from the original, right? But what about negative x to the power of 3? That will be negative, so we're going to write minus x to the 3. Negative x squared is x squared, so this stays negative 8x squared, so the negative stays negative. But then we have a 2 times negative x, so minus 2x plus 3. Do you see how the even powers, that it stayed the same, and then the odd powers changed sign? Do you see that? Okay, so Descartes' rule of signs is dependent upon the number of times the signs of the terms in the equation change signs. What does that mean? We don't know what that means yet. Circle it, highlight it, whatever. Do change signs, okay? In the boxes below, write both the equation of p and the equation of p of negative x. Then count the number of times the signs of the terms change. You ready? Okay, on the left, we're going to write p of x. And on the right, we'll write what we found for p of negative x. Okay. The whole point of Descartes' rule of signs is to see the number of times the signs change. Are you ready? Are you ready? Here we go. So, what does it start off as? Positive. Does it change? Here, we're going to make little waves. Positive to positive. Does that change? No. Positive to negative. Let's write yes. It changes right there. Yes. Then we go from negative to positive. Is that a change? Yes. Then positive to positive. Is that a change? No. So how many times does this change signs? Twice. Good. So 2 times. 2 sign changes. Okay. Now we're going to look at the negative one. The negative one, we have a positive. We start out positive here in front, and then it goes to negative. So is that a sign change? Yes. Is negative to negative a change? No. Negative to negative again? No. Negative to positive? Yes. Okay. Look at all these notes down here. Let's highlight, annotate, understand. The number of sign changes in P of x determines the maximum number of positive real roots that the function could have. Positive roots. That means like on the right, okay? Positive roots. The number of sign changes in P of negative x determines the maximum number of negative real roots that the function could have. This is thrilling, right? You're like, I've been waiting my whole life to know this. The function can have this maximum number of positive or negative roots or any multiple of 2 less this maximum. What? For example, if a function can have a maximum of 4 positive roots, then it could also have 2 or 0. They come in pairs, okay? So if you got 4 sign changes, then it could have 4, 2, or 0. If a function can have a maximum of 3 positive roots, then it could also, what's 3 minus 2? 1. It could have 1 positive root. If a function can have a maximum of 2 positive roots, then it could also have 0 positive roots. Okay, what were those patterns again? 4, 2, 0, 3, 1, 2, 0. Okay, that's what we're going to see to start with, and we'll get more examples if we need to. Okay, so for this function, how many positive roots are possible? Well, what was the sign change? What was the sign change? 2. So we're going to have 2 or 0. So 2 or 0. Where'd the 2 come from? The number of sign changes, because that's Descartes'